So, example number 3 asks me to find the determinants of matrix A and B from example 1 using your graphing calculator. So, the way that I'm going to do this is I want to use my matrices, but I want to do some math on them. So, I'm going to press second matrix or second inverse button. And sure enough, you'll notice that in between names and edit, you see the word math. So in order for us to get to that menu, you just press the right arrow once, and now you have a list of things. Determinant, choice 1, DET parenthesis, is short for the calculator language of determinants. So all I'm going to do is just choose choice 1, and I'm going to do matrix A by pulling up its name the way I do with operations, and then close the parenthesis and go ahead and press enter. So now it will actually compute that value for me without having to do much work at all. If you want to try finding the determinant of B, feel free, press pause, and when you're ready to check your answer, press play. Okay, so at this point, you should have found the determinant of B. So to make sure you have the correct answer, we're going to do second inverse math, which is where everything's pretty much stored. Choice 1, determinant, followed by tell the name, matrix B, which is going to be choice 2. Close the parenthesis and press enter, and voila. If this is the decimal you got, then you got the correct determinant from B. So you can only imagine how more rigorous finding the determinant by hand would have been without a calculator. So when you're ready, let's move on to number 4. So the thing to worry about when you input number 4, the directions say, solve the following systems of equations with your calculator, round your answer to the nearest thousandth, and be careful to put a 0 placeholder for any missing value. So if we count the number of rows, there are 6 equations, and there are the letters A, B, C, D. None of these have E, so we're not going to count that. We're up to 4 so far. F, G, and if we're going to do the augmented matrix, we also want the solution column. So we have a total of 7 columns. So that's why I've inputted matrix A as the matrix, 6 rows by 7 columns. So my top row, 1, 2, -4, -3, 2, 5, and -1. Even though it skips the letter E, the calculator doesn't know that, so you just can leave that out completely. You don't need to put zeros in for E's. 4, 1, 0, 0, because there's no C's in the second equation. 6, 50, 90. Ooh, I caught a mistake. That's why it's always good to double check and make sure that you've entered them correctly. 2, -1, -5, 0, 1, 5, 4. Next row down. 8, -6, 7, 8, -6, -8, 10. -2, 50, 9, 9, 2, -5, -3. And my last row, that should say, notice again, we caught this now. Before I say, wait a minute, I made a mistake. No, I did not. There is no A in that last equation, so that's why I put a 0 for the first column, 6, 5, 0 for D's, 90 for F, 18 for G's, and 360 for my solution. So now that I've made sure that I've entered this correctly, I'm going to go ahead and get out of this menu. And the way in which we're going to do this is to use row reduced echelon form. So you should already have a rough idea of how to do this. If you don't, and you still have to enter your values, go ahead and press pause. And when you're ready, press play. And now that you're ready, we're going to go ahead and press second matrix. Remember, row reduced echelon form is found underneath the math menu. It's towards the bottom, so it's actually easier to press the up arrow or faster. And it's letter B. And then we're just going to tell it which matrix we want it to solve. So in this case, we're going to pull the name A, which is the first choice. That's because I overwrite my first matrix A. It's not the end of the world. And go ahead and press enter. and look at those numbers. Now, this said to round to my nearest thousandth, so here I have a little bit of a clue. My answer should be 0.809, negative 0.790, 1.73, 2.41. Actually, if I go back for a second, 1.729, 2.414, 3.695, and 1.308. So if you need to go back and look at example 3 or 4 again, feel free. Otherwise, move on to the last page. So on the third page in the box, it says Cramer's rule. This is another technique to solve a system of equations. However, unlike the augmented matrix or row-reduced echelon form approach, each variable is solved independently or by themselves. This is a wonderful time saver when only a few variables will need to be solved for. So for a given system of equations, let A equal the coefficient matrix and let B be the n by 1 solution matrix. Variable x sub I is equal to the determinant of matrix A with replacement B divided by determinant A, where A sub B is the matrix A with B substituted in the column for x sub I. So in example number 5, suppose we wanted to solve the following system. 3x plus 2y minus z equals 5, and 7x plus 9y minus 8z equals 15, and 6x negative minus 48y plus 50z equals 150. So matrix A would be all of the coefficients on the left sides. 3, 2, negative 1, 7, 9, negative 8, and 6, negative 48, 50. So I've already taken it upon myself to enter this first matrix A. Matrix A sub B, if I get out of this, needs to be a different matrix. So I'm going to go into my matrix menu, and I talked a little bit about this before, so if you've missed this, you really can't delete matrices, you can only overwrite them. And the way you do that is you go to the edit menu, and if you see here, my matrix B is still the old 4x4. Well, to overwrite it, you just enter it like it was never entered in the first place. You're going to, under the edit menu, choose matrix B, and you're going to tell it what this is going to be. So since it's going to be the same size as matrix A, or a 3x3, that's what we're going to tell the number of rows and the number of columns. The only thing is, instead of replacing that first column, because I'm solving for x first here, instead of actually putting in the coefficients of 3, 7, and 6, I'm going to put in that first column the solutions of those equations. So 5 would replace 3. Then the rest of that row coefficients would stay the same, 2, negative 1. Then my next row, instead of entering 7, I'm going to put 15. Then A will remain the same on that row, 9, negative 8. And last but not least, the bottom row, we're going to change, instead of putting 6, we're going to put 150 in. And again, that last bottom row from there stays the same, negative 48 and positive 50. So now that I've entered my values, I can go ahead and press second, quit. And now all I want to do is just take the determinant of that matrix B, in my case, divided by the determinant of matrix A, which is the coefficient matrix. So we showed you earlier in this lesson how to do that. We're going to go to second matrix, math, determinant, choice 1. Now I want the matrix with the solution substituted for the variable I'm solving for. So I'm going to do determinant B divided by, make sure you close that parenthesis, determinant, matrix A, choice 1. And one side note, you notice that I didn't put determinant in front of matrix A. So to go back and enter it, press second, DEL, and you'll notice that the cursor on the screen changes. It's like appearing, disappearing. So all you have to do is do second matrix, and you want math, and you're going to tell it what you want it to do, so it's determinant. So in other words, one determinant does not work for both. You actually have to enter them both as determinants. And then once you have it finally put in the way you want to, just go ahead and press enter, and there's your answer for x. So now that you've seen how I've done this, it's just the determinant of the coefficient matrix with the variable I'm solving for replaced with a solution divided by the determinant of the original coefficient matrix. Go ahead and try solving for y and z, and when you're ready to check your answers, press play. So if I want to solve for y, this is what your matrix should look like in the numerator: 3, 5, negative 1, 7, 15, negative 8, 6, 150, 50. And since I now have this set up the way I want, the nice part about this is since I rewrote matrix B, all I have to do is press second enter, and it'll give me the last entry, which is the determinant of my now new matrix B divided by the determinant of the old matrix A, which is the coefficient matrix, and press enter. And that should be my answer for y. And now to find z, this should be your matrix that you should be using for the determinant of the numerator. Going across the row: 3, 2, 5, 7, 9, 15, 6, negative 48, 150. So like we did before, we're going to get out of this menu. We're just going to do second enter because our new overwritten matrix B is what I'm finding the determinant of in the numerator, and press enter. And voila, negative 11.25. So now you're probably wondering, how can we verify that 7.2115, negative 13.942, and negative 11.25 are my answers? Well, I could always do row reduced echelon form to double check this. So second matrix, I'm going to choose matrix C to actually edit. And I'm going to enter the augmented matrix. So there are 3 variables with a solution column, and there are 3 equations. So a 3 row by 4 column, 3, 2, negative 1, 5, 7, 9, negative 8, 15, 6, negative 48, 50, and 150. So again, what I just showed you is just an alternative to doing row reduced echelon form. So if I get out of this menu after double checking really quickly just to make sure I have all my right numbers, looks like I do. So second mode, I'm just going to do second matrix, math, row reduced echelon form, matrix, C. And I should get the same exact answers that I just got separately for X, Y, and Z. And sure enough, I did. So I know I've done it correctly. If you need to watch any part of this video again, feel free, and then move on to the homework.